Hello, students. Today I want to talk to you about three different definitions pertaining to matrices. The first definition is the determinant of a matrix. And it says the determinant of a square matrix is a numerical value that gets associated with the matrix. So basically, the determinant is just a number that gets associated with a square matrix. And the symbol for finding the determinant is either DET. So I could ask you to find the determinant of matrix A by writing the determinant DET of matrix A. Or I could say, here's matrix A. I can write it in absolute value bars, and that's another symbol for the determinant. Now, the way we're going to calculate the determinant is technologically. There's a mathematical approach and a process for finding determinants, but we're taking our course with the graphing calculator. So the way you're going to find this determinant, the way you're going to find this numerical value, is you're going to go to the matrix menu. You're going to go to second and then inverse for matrix. You're going to move the cursor over once to math, and then option number 1 stands for the determinant. So the determinant is just going to be a number that gets associated with a square matrix. So let's go about finding the determinant of these three matrices. So first, to find the determinant of matrix G, what I'm going to do is I'm going to go to second and matrix and choose number 1 for determinant. And then here, since I'm just using these matrices once and then kind of moving on, I'm going to use the alpha zoom template to set up my matrix. So here I'm going to go alpha zoom. I'm going to set up a 3x3 matrix. And then I'm going to enter in the entries, enter in the numbers for this matrix. When I press enter, here the calculator tells me the determinant is 98. Remember, the determinant is just a numerical value. It's just a number that gets assigned to the matrix. So here the determinant of matrix G is 98. Okay. Let's go about finding the determinant of matrix H. Now matrix H is a 2x3 matrix. It has 2 rows and it has 3 columns. So I'll say find the determinant of a 2x3 matrix. I'll enter in matrix H, and then when I press enter, my calculator doesn't like what I typed in. Now, why am I getting this error message? Well, look back at the definition of the determinant. It says the determinant of a square matrix. Your matrix has to be a square matrix. Matrix G was a 3x3 matrix. Matrix H was a 2x3 matrix. That's not a square matrix. That's why matrix H has no determinant. So you just can't take any matrix that you might meet on the street and try to calculate its determinant. It has to be a square matrix. Take a minute, try to find the determinant of matrix I on your calculator. Here, the determinant of matrix I turns out to be 0. And that's actually going to be pretty significant that the determinant turned out to be 0. Right now, it seems like we're not really doing anything. We're just trying to find a number that gets associated with this determinant. But you're going to see over the next few weeks, determinants are very, very useful in mathematics. So that's our first definition, the determinant of a matrix. The second definition I want to go over with you today is the identity matrix. And the identity matrix of a square matrix that has the number 1 from upper left to bottom right in the matrix and has 0 as the rest of its entries. So take a look at these two examples I'm giving you here. This first one is an example of the identity matrix of a 2 by 2. Notice it has 1s along the main diagonals and 0s every place else. So that's the identity matrix of a 2 by 2. Here's the identity matrix of a 3 by 3. Notice it has 1s along the main diagonal and 0s every place else. Now, what's the significance about this identity matrix? Well, basically, the identity matrix is the way of writing the number 1 as a matrix. See, when we deal with traditional algebra, 1 was called the identity element. Well, for matrices, the way we write the number 1 is by using the identity matrix. So if I wanted to know what the identity matrix of a 4 by 4 matrix would look like, it would have 1s along the main diagonal from upper left to bottom right, and then 0s for every other entry in the matrix. So basically the way I would write the number 1 for a 4 by 4 matrix is this way. Now, it doesn't seem like the identity matrix has a lot to it. It's like, okay, this is the way I write the number 1 as a matrix. Well, we're going to be using this identity matrix when we talk about our last definition, the inverse. Our last definition is called the inverse of a square matrix. And here's how this works. The inverse of a square matrix is a matrix that, when multiplied by the original matrix, yields the identity matrix. Now that, and I'm a math teacher, that's confusing. Let me explain how this works. You take a matrix, and if you multiply it by its inverse, you end up with the identity matrix. So basically, if you take a matrix, like matrix A, and if you multiply it by its inverse, and it's the same symbol for inverse, the exponent of -1. If you take a matrix and multiply it by its inverse, you get the identity matrix, which we talked about up top here. So look at this first example. Is matrix B the inverse of matrix A? So what we're going to do is we're going to take matrix A and we're just going to multiply it by matrix B. And we're going to do this directly on our calculator. And how are we going to know if matrix B is the inverse of matrix A? Well, if you take a matrix and you multiply it by its inverse, you should be left with the identity. So we're going to do this product on our calculator. If we're left with the identity of a 2 by 2 matrix, then matrix B is going to be the inverse of matrix A. If we're not left with this identity matrix, then it's not the inverse. So enter that product onto your calculator. And notice here that the resulting product is the identity matrix. So is matrix B the inverse of matrix A? The answer is yes. For this last one, they're giving you matrix X and they're asking you to find its inverse. Now, when you need to find the inverse of a matrix, you should use the regular inverse button, just like you would do to find the inverse of a number. So let's enter in matrix X, and let's find its inverse. So what you're going to do is you're going to enter in the matrix. and then press the inverse button to get the inverse of matrix X. So here is the inverse of matrix X. It's a 2 by 2 matrix. 3.5, -1.5, -2, and 1. And again, what's the significance about an inverse? Well, if you take a matrix and if you multiply it by its inverse, if you take matrix X and multiply it by its inverse, what should happen? You should be left with the identity matrix, because that's the significance of what the inverse of a matrix is. Let's try to find the inverse of two other matrices, and then you'll try some of these on your own. Let's find the inverse of these two matrices, and we're going to do this right on our calculator by using the inverse button, the x to the -1 power button. And for this first one, when you find the inverse, it looks kind of sloppy. You have all these repeating decimals. Now, what you can do on your calculator is this when you have really ugly looking matrix answers. What you should do is just convert your answer to a fraction, just like you convert a number to a fraction by pressing the math button and then going to option 1. So here's a nicer way of writing the inverse of that first matrix. Take a moment, try to find now the inverse of this second matrix. Just like before, enter your matrix and press the inverse button. And when you do that, you're getting another error message. This time it says error singular matrix. And here's the last definition. A singular matrix is a matrix without an inverse. There is no matrix that if I multiply it by this one, there's no matrix that will give me the identity. So not every matrix has an inverse. Matrices without an inverse are called singular matrices. Now what I want you to do is work on the remaining problems for this assignment.